Alright, so in this video I want to show you how to obtain the Atterberg limits. Atterberg limits consist of two main soil properties, the liquid limit of the soil and the plastic limit. The liquid limit of the soil is the lower limit of the viscous flow, and the plastic limit of the soil is the lower limit of the plastic state. The difference of the liquid limit and the plastic limit is called the plasticity index, which shows the range for range of water contents where the soil behaves plastic. In order to run the test for a liquid limit, we need a device called the Casa Grande cup and a grooving tool, which I'll show you in a second. But before that, we'll need to obtain a sample of the soil that we're testing. In this case, we're testing some kaolinite clay, which you can see right here. So brown looking, pretty moist kind of clay that's going to be used for this test. You can see that I can easily mold it into any shape. So it's not too dry, it's not too wet, somewhere in the middle. So I'll be using that. I'll be using evaporating dishes. These are little aluminum cans that I use and I label, right? In the case that you were testing this soil in the lab as a part of your group, you would grab one of these evaporating dishes, and whenever you have a sample, you'll put a little piece of your sample into the evaporating dish and then into the drying oven. The reason for doing that is to get the moisture content of the soil that you're testing. Right. Another tool that I'll use in this test and generally pretty frequently in the soils lab is this, which is a spatula. Right, it's something that I can work with the soil generally. And I have this china dish where I'll be mixing some of the clay with some water. Right. So in order to do my liquid limit test, I'll grab something roughly around 100 grams of the soil that I want to test, and I'll place it into my china bowl. And depending on the state of it, right, if it's too dry, I probably want to add some more water to it, get it fully mixed, and have the water mixed into the soil pretty consistently within the entire sample, then place it into the Casa Grande cup, which I'll show you in a second. All right. So in this case, I'm gonna not use all of this because it's a little too much. I'm going to save some of it later for my plastic limit test, but what I'll do is I'll just spread the clay into my china bowl. Alright, so as you can see, I have the soil spread out. I still haven't added any water to it, but I'll grab one of these water squirters. I use deionized water. I'll add some water, not a whole lot, just a little bit, and I'm going to add the water, mix the water with my soil, and turn it into a pretty uniform mixture. You can see that it's pretty firm, and obviously as I add more water to it, it'll get softer. So the idea with the liquid limit test is to place it into this Casa Grande cup, create a groove using that grooving tool through it, as I'll show you, and then measure the number of blows with this automated blow count measure to see how many blows it took for that groove to close by 1/2 inch, right? So you'll see that in a sec. So I'll add a little bit more water and fully mix again. So once I have a uniform mixture of this clay slurry, I'll grab some of it and I'll put it into my Casa Grande cup, and you do this kind of motion. Need a little bit more. Something like that, and I'll clean the sides, and I'll create a groove going through the middle all the way to the end. So that's, I'm going to do a close-up of this so that you can actually see it from the top. So that's our groove, and so now I have my sample in here, and I'm going to start the machine, and it's going to start dropping. I'll turn off the machine when I see that my groove is being closed, and the amount that it's closed is closer to 1/2 inch. So right now what you see is that the groove did close. So see that closing? It is closed, and it is around 1/2 inch, and the number of the blows is actually 46, right? Typically what you want to target are number of blows between 10 and 40. So this 46 that we have means that our soil specimen is a little too dry, and what we'll need to do, we actually won't take a sample of this since it is too dry, but what we'll do is grab whatever's in here, place it back into our china bowl, and since it's dry we need to add more water, then repeat the test. So what I'll be doing right now is I'll take all of this in, add a little bit more water, mix it, and at the same time I'll need to, in order to repeat the test, I need to grab this and clean it off of any soil that's in here, give it a rinse, and then dry it, then have it ready for the next test. So I'll have my assistant help me with that, and in the time being I'll add more water and mix the soil that I have in here as we did previously. So now that I added more water, it's a lot easier to work with the soil. It's much more softer now. But I want to continue mixing until I get a uniform paste. I don't want to test a paste that's not uniform. The reason for that is that you'll have more moisture in some areas of the soil and you'll have less. So you want to get it first to that consistent paste level, then test it. I think this is pretty uniform, and I'm going to place it one more time into the Casa Grande cup. So I'll put it in and do this motion with my hands. Get the excess stuff off from the sides. And clean up my grooving tool first so that I get a nice clean groove, and then repeat it. Let's see what we get this time. So that's our groove. And I'm going to reset the number of blows to 0 and turn it back on. So this time, our groove closed up in only 24 number of blows. Actually, this is very, very close to the liquid limit, because the liquid limit of the soil is defined the water content at which you have 25 blows. So typically what you'll need to do is run 4 to 5 tests and try to target blows between 10 and 40. Then regress the data and doing the regression, pick off the moisture content at 25 blows. So in this case, I will grab a sample of the tested soil. Typically you would need to do this a little bit faster so that the water or the moisture doesn't evaporate. So I'll grab a sample of this, place it into the evaporating dish, something like this. It has to be labeled, as I mentioned earlier. This has a label right here. And then we place it into the oven. So the first thing to do is to weigh the evaporating dish while it's still empty and there's nothing in it. So I label them, put a name on it, right? Then I come to the scale, make sure that my scale is tiered and showing 0. Then I weigh the can. So for example, this can is weighing 11.43 grams. That's the first step. Once I'm done measuring the empty cans, I will place a sample of the soil that I tested and want to get the moisture content for. I place it into the can, as you can see in this one, and then I remeasure it again. So in this case, the weight of the can plus the wet soil is 22.57 grams. I make sure to write that down somewhere in my notebook. Then I place the can with the wet soil into the oven. I then close the oven door and have it set at a temperature of 100 degrees and let the soil sit in the oven for 24 hours before I take it off. Once I take it off, I re-weigh the specimen, or in other words, the dry soil in the can. That way, what I can calculate is the mass or the weight of the water that evaporated during the time that the soil or the wet soil was in the oven. Okay? And using the relationships, I can find the moisture content of the soil. So the last step is to grab the soil that was in there, and since it was at a number of blows of about 24, we can go either way. We can let it dry out a little bit more and then test it, or we can add a little bit more water and redo the test. Obviously, by adding more water, we'll be getting a number of blows that are going to be below 24 this time. So again, I'm going to repeat the same procedure. So try to get a uniform, consistent paste in my clay. Then when I have that, I'll place it back into the Casa Grande cup, create my groove, and have the machine run one more time. Okay. Can you So added some more water, and I have another uniform paste here, and I'm going to grab and place into the Casa Grande cup. Then doing my groove. And setting this back to 0 and having the machine run. So this time, as you can see, the groove is again closed at about 1/2 inch and the number of blows is about 15. So this is another valid data point that I will also grab a sample from and place into the oven. Okay. So this is my evaporating can, and I'll grab a sample, measure the weight of this wet soil, and then place it into the oven, and then come back in 24 hours and measure the dry weight of it. Okay? So the next step is to get the plastic limit of the soil. So in order to do the plastic limit test, I have a tube that is mainly my reference point for being close to 1/8 of an inch or 30 millimeters. And what I want to achieve is basically by rolling the soil with the palm of my hand into a thickness at around that 1/8 of an inch, but I also want the soil to start crumbling at that thickness, right? That will be my plastic limit. I'm going to do it one more time. It's actually a little too big, maybe. Just use half of that. Not quite there. If I can go thinner than that thickness of 1/8 of an inch, that means that the soil's too wet and I may need to put it back together and start rolling one more time. So getting quite close to that thickness of the 1/8 of an inch, but no, not a whole lot of crumbles really. And so these are around the thickness of that tube. So what I'll do is I'll grab these samples, place them into one of those evaporating dishes, and put them back in the oven to measure the moisture content of these soil samples here. Okay, so I'll measure the weight of the wet ones here, and then I'll measure the weight of the dry ones after I bring it out of the oven, although this is probably not the best amount to go with. So what I'll do is I'll hold these and I'll place something on top of it so that the moisture does not evaporate, and then I'll add a little bit more sample to it. Typically, if you can get something around 5 or 6 grams of the sample, that is probably good enough. So what I'll do is I'll start rolling again, trying to get a little bit more of that sample. Oh, there we go. At the thickness, and I'm crumbling, so this is the perfect stuff to grab. So I'll grab these and I will add them to my other samples, and then I'll weigh the wet soil here and then reweigh it after drying. That'll give me the moisture content of the soil at its plastic limit. So I'll repeat the test once or twice to be able to have different values, and I'll take the average for the moisture content and report the plasticity or the plastic limit. The difference of the liquid limit and the plastic limit will give you the plasticity index, which will then help you designate the location of your particular soil sample on the Casagrande chart. On the Casagrande chart, you have on the x-axis the liquid limit, and on the y-axis the plasticity index. So with getting the liquid limit and the plasticity index, you'll be able to locate where you will fall on the Casagrande chart. Okay? Thank you.